back to my channel. Today we're gonna build a regression model and deploy it to Webapp. So here's the final product of what I'm gonna show you how to create. So this is based on second-hand used car data from Cargo, and these cars are from Canada, and it has the number of mile, which year it was produced, and the maker, and something like that. So I've trained this model, and if you put new data and press calculate, then this model will return the reasonable price for this car with this specification, and under that it will show the reasonable range of price. So for example, if the car is under $4,000, it's very cheap, and between 4,000 and 11,000 it's reasonable price, and over 11 it's expensive. Of course, the range is very big, but I will show you the logic behind. Let's go for hands-on practice. So we're gonna be starting from modeling. So we're gonna use Untitled Chapter lab in order to do experiment and make model. And after that, we're gonna be packaging this model into our app. If you wanna skip the modeling part, you can go straightly to the packaging part. I will mention the section below in description, so please go ahead. For now, let's start modeling. We're going to be importing pandas, numpy, matplotlib, scikit-learn, so we're not gonna we're not gonna use like a neural network. We're gonna use like several models from scikit-learn, and we're gonna import the data. And let's check the data. So here's the data. It has car ID. I don't know what it is. I think this is serial number, maybe. Price, mile, stock number, whatever. And we need to do some data wrangling in order to remove unnecessary data. So let's see the type of data first. So we're gonna see the type of data for each column. So we have ID bin as non-float. I think it's ordinal data. Make model by type. Yep. Categorical data. So let's filter out categorical data and see what is usable. So now we are looking at the nature of data and drop the unnecessary data. So in order to do that, we're gonna only filter those data and have a look. So let's just filter all the objective. Not like this. Okay. Okay. ID. Bin. And what else? Stock number. Make and model. Trim also. Body type, vehicle type. Okay. Drivetrain, transmission, fuel type. Engine block, seller name, street, city, state, zip. I'm not gonna include this seller name, street, city, state, zip. I don't think it doesn't have anything to do with the price. So let's see what is not usable or not usable. So obviously ID, it's unique value, so it's not really related to our model. And also VIN, it looks like very unique data too, and stock number too. So, and other than that, it's just brand name, model is car model, trim, body type, vehicle type. Yeah, I think it's I think from make to engine block, it's all usable. So we're not gonna include this ID VIN stock, yeah, and all the columns related to seller information. So calls to drop. ID VIN, stock number, and seller name, street, city, state, zip. Yep, all clear, all good, and TF drop. You want to drop entire column, so put 1. If you just want to drop the row, then you put 0. And let's see our shape. We have 390,000 rows with 13 columns, and I think it's enough data to train our model. Sorry guys, actually I'm gonna include the state because I already made the application with state. So I just want to stick to same process. And if you want to drop it, well, you can try it. Yeah. And let's see if there's any null value in our data. There are so many null value. Well, the maximum is like 90,000, which is like 20% of the entire thing. But it's still 300,000, so I don't think we need to impute data by min or mode. So we're gonna just drop it. Drop any. Shape. Yeah. I mean, it became 260, 270 rows, but I think it's still enough to train our model, so it's okay. If you want to know how to impute, well, try to Google it. Yeah. Okay, so just to make sure there's no null value, so there's no null value, and let's check it. Yep, the data looks much cleaner. So price, this is gonna be y value, and rest of them will be x value. And let's see how many unique values there are. So make, there are a bunch of makers, and we're not gonna use them all. We are only gonna train Honda and Toyota, because if you train all these, the dimension will be very big and it's gonna take a lot of time. So since the purpose of this video is to show you how to package and make it application, I'm not gonna really focus on the accuracy of the model. Alright guys, so I just did some things to see the unique value of each column. So I just jumped over because it took so much time to type. And so if you have a look at here, make, we have a lot of maker. But if you have a look at some name, there is hyphen between alphabetical letters. So hyphen is treated as operator in Python. So just in case to avoid problem error, we will replace it into underbar. So this code is how that is done. Yep. And for body type, we did the same thing, and I just wrote the code to see all the unique value of each column. For fuel type, since there are so many types of fuel, I just bundled them together into 4 categories: gasoline, biodiesel, hybrid. Yep. Please have a look from the Github, and I will just jump this process. So from now on, what we're gonna do is that since we have this data which is cleaned, you're gonna filter the data that has at least at least two rows in unique for each unique data, because if there's only one row for one unique case, it's not going to be trained well, because you're going to split the data into test data and validation data. So we'll need to have at least two rows. Yep, now we filter the data which has more than two rows for unique make and model. Oops. So this is how it looks, and we're gonna save it to the CSV file. I'm gonna save it into data. Without index. Yep, it's saved, and from now we're gonna be doing modeling. So in this part we're gonna look at the correlation between price and each columns. And there are two types of data, which is numerical and which is categorical. So we will approach two different methods to each type of data. Okay guys, so welcome back to modeling. We'll be filtering which columns really related to the Y value, which is price. We're gonna do the correlation test, but first we have to import the data we had saved. Just to check if the data is saved. Okay, the data is saved, and first we will do the correlation test. Let's see. So if you run just correlation, it will just pick up the continuous variables. Let's see. So for data, yeah, it's resolvable. So mild and data price, it has negative relationship. Year, well, it's true too. I mean the if the used year is big, it has negative relationship. But since the year in this data is not in the like how many years, but it's the data of when it is manufactured, so I think it's reasonable. Engine size, yeah, yeah, I mean it's okay too. But the thing is, the correlation is not really high enough. Usually like I don't know. Usually we if it's higher than like 0.6, it's good. But yeah, just keep in mind the data itself is not really correlated and to the y variable, so eventually the accuracy will not be very good. So um, next we will have a look at the categorical data. And next is that we're gonna see which categorical variable is related to the price. And before that, we're gonna do the train and test set split in in order to do the test. So here I just copy and pasted the code from the previous notebook, because I think typing everything is a waste of time. Yep, and next we're gonna do the test. Again, you can have a look at the Github, but I'm gonna explain briefly. So we're gonna collect the categorical variable index and isolate it from the original data frame. So these are the index, and assign it to a feature name. And so since it's columns and index, it will pick up the column names, and we're gonna make pipeline from sklearn, and we're gonna encode with ordinal encoder. So what it does is that it encodes every unique value from column from each column into 0 and 1, so it can be fit to the regression model. And second, we're gonna use the regression model to select the most highly related value. It's selected out of a coefficient and p-value, and we're gonna select the top 50%. And rest of it is just fitting the model and printing out the top related column. Alright, it's done. So the top related variables, maker, model, and trim, body type, and state. Yep, and with these features, we're gonna make model. So from now on, this is the notebook I've created. I did modeling. Since typing every code is so inefficient, I'm gonna just explain. So we gonna import the clean data, and according to the correlation test, we're gonna pick up the columns with only high correlation rate. So we're gonna drop these columns, and this is the final data set that we're gonna use. But for now, we're gonna only train the model with only Honda and Toyota cars, because there are so many makers and so many models, and dimension is gonna be very big, and it's gonna take a lot of time. And also, if the dimension is big, we're gonna need a lot of data, and the accuracy will go down. So alright, we save the data with only Honda and Toyota cars into the CSV file, and we import it again and did the test and train data split. And we also did some categorical data encoding by isolating categorical data and encode it with one hot encoder. And what it does is that it does the same thing as ordinal encoding. It transforms into 0 and 1s, and And this is a processor, and first we're going to use gradient boosting regressor. If you don't know what gradient boosting regressor is, please look at the YouTube link below in the description. Fit the model and we see the score, and the accuracy is 0.59. As I told you, because the data is not really correlated to the price, we cannot expect high accuracy. But there's something we can do, which is feature engineering, and try other models. But feature engineering, since the data is very complex, we're gonna skip it because it's gonna take a lot of time, and we'll just try the 3 other models, which is linear regression, and random forest, and XGBoost. So these are the score. For linear regression, it's better than gradient boost, 0.62. For random forest, and it's 6.7. XGBoost, it's very similar, but random forest is a bit higher. What we want to do is that we want to also see the mean absolute error and mean squared error. Well, yeah, it's like the difference, the error between the mean error between predicted and actual price is like almost 4,000. So not so great. But with that, there's another metric that we wanna see, which is the cross validation. So these are the code that visualize the cross validation. The red and green is the respectively MSE, which is mean squared error. So for all 4 model, the MSE of training and cross validation is very close, so there's no overfit or underfit. But if you look at the random forest, it shows the raw score, raw score for both training and validation score. So I'm gonna choose a random forest model, and I save the random forest model into model joblib file. And with this joblib file and the final data, we're gonna make the web app. Alright guys, so I'm going to explain how the application is made step by step. Again, I'm not going to code everything from the scratch because I think it's meaningless. But I want you to really understand how the flow works. So first of all, we import all the necessary libraries. So Streamlit for making web app, and NumPy to set the data type, and joblib to load our saved model, and pandas to save the our data. So first of all, we're gonna set the two function, which is load data and load model. And for cache data and cache resource, this is something unique from Streamlit that makes cache data. So every time the web app reruns, it doesn't have to load the data and model from the scratch again. It's saved in cache data, and it's gonna be much faster. Yep. And we're gonna go all the way down to the our front end page. So we're gonna set the code to only run when there's command to run on terminal. So this is the code we use. So the code under this name equal main will run only if it is commanded on the terminal. So we're gonna set the title as use car price calculator, and we're gonna load the model as pipe, as we saved from the Jupyter notebook, and we're gonna set the form with the 4 columns. And in the column 1, we will set number input for mile and model columns, and column number 2 we're gonna set the input box or select box for year and engine size, and like the same for and so on. And what we did is that we set the variable with the title mile and the value which is default value, and set the minimum value and step, I mean the interval of the data you can put it. This is unit of data you can change, and the key set as mile. Setting key here is very important because we're gonna use session state, and I'm gonna explain what session state is later. And it's same for every other column. So model index, this is default for select box, and key we set it as model, same as the title, and give option like this. So we use number input and the select box, so every variable works the same, and there are so many options, so I had to spend a lot of time inputting this. And after all the value is entered, we can set the button, form submit button, and set the title as calculate, and type primary. So primary is red button, secondary is white button, and on click we're gonna run the make function, make prediction function, and set the model. And I'm gonna explain the make prediction function from now on. So make prediction function, we're gonna use session state. So what session state is that if you use session state, even if the page reruns, the input you put until now stays the same, so it's kind of cache data. But if you don't use session state, the input we have input until now is all gone. You have to input from the start, so that's kind of annoying. So that's why we are using session state. And remember the key value, we put all the key value here and assign it to the variables. And we transform those assigned values from the select button or input box into MP array, so it can be input into our model, which is pipeline. And with the pipe, which we got from the model load function, we say predict and input these values, and we round it into 2 decimal point, and also assign it to the session state. And these are the mean absolute error that we're gonna use to calculate the price range, which is reasonable, which is not, something like that. And yep, we're gonna also assign it to metrics. And after getting metrics, they will be shown on the subheader and the metrics. So okay, so if you click the make prediction, so make prediction function will return the values of the session state pred and session state metrics. So the result will be the estimated car price is going to be the blah blah blah, the number, predicted number, and the for 3 markdowns, the result will be the pred value plus minus or the mean absolute value or something like that. And here we use the HTML. How we use HTML, we also assign it to the definition, the function, and this is the template for HTML. So we assigned like a rectangular outlier to distinguish it from each other, and put the also color, set the color here, and that's pretty much it. I will show I will show how it works, and okay, so this is the final project, final product. So you can input the mouse and here and select the maker and select the trim, and let's say SUV, and Honda Accord, calculate. Okay, it's gonna be the price, show the estimated price, and it's gonna show the minimum what is it, price, and the maximum price of the reasonable price range. And I hope you liked it, and please look at my GitHub and try it yourself, and hope it helped you a lot. And if you liked it, please consider buy me a coffee, and subscribe and click like button, and thank you. Enjoy. Bye.